Stephen Hawking, the brilliant astrophysicist, is no longer with us, but his legacy continues to thrive to date. The recently launched James Webb Space Telescope is highly anticipated to focus on some of these late British scientists' intriguing theories. One of these hypotheses is the last one Stephen Hawking worked on before his death. He argued for a multiverse theory, in which an exact replica of ourselves exists in another universe. How exactly would the multiverse theory work, and how would it be proven? Let's find out. Stephen Hawking died in 2018, more than 3.5 years before the launch of the James Webb Space Telescope. This was due to a series of delays that pushed the debut date back from 2007 to 2011. It also sucked up roughly $10 billion, which is 10 times more than the original estimate. Following its successful launch and deployment of its components, this powerful space telescope must undergo several months of calibration and testing before it can begin its mission. The telescope will be able to peer into the atmospheres of planets outside our solar system and peer through massive clouds of dust to watch the birth of new stars and planetary systems, thanks to the large 6.5-meter giant mirror that had to be folded during launch. And although the universe is estimated to be 13.8 billion years old, JWST will be able to collect and reflect light from the beginning of the universe. It will also be able to observe light from the earliest stars and galaxies close to the Big Bang. The JWST is an infrared telescope, which means that it detects objects in space by means of infrared radiation. As a result, it can observe celestial bodies, such as stars, nebulae, and planets that are either too cool or too faint to be seen by the human eye. According to NASA, infrared radiation can penetrate through gas and dust, which look opaque to the naked eye. This contrasts with the Hubble telescope, which sees visible light, ultraviolet light, and near-infrared radiation. To function, the instruments on board must be kept at extremely low temperatures, -370 degrees Fahrenheit or lower. The enormous sun shield keeps the equipment cool by shielding the telescope from the sun's heat. According to a report published in 2018 by an independent review board, there were 344 single-point failures or tasks that needed to be completed for the mission to be successful. However, in December of last year, the telescope was packed inside the nose of an Ariane 5 rocket and safely launched from the European Space Agency's spaceport in French Guiana. After the launch, it detached itself from the rocket and began to unfold. According to NASA, the first deployment occurred roughly 30 minutes after launch when the solar panels opened, allowing the telescope to draw power from the sun. Many astronomers are vying for time with the JWST telescope because of its capabilities. The Space Telescope Science Institute, which supervises Hubble and JWST science operations, had issued a request for proposals from astronomers on how they wish to use James Webb, with 6,000 hours of observation time up for grabs. The lucky ones have finally had their projects approved, and we are looking forward to the wealth of information they will provide to us. With nearly 20 years of operation guaranteed by the amount of fuel aboard the Space Telescope, the JWST has plenty of time to unravel the deep secrets of the universe. Hawking's multiverse concept theory can finally be tested after the JWST arrived at its destination 1 million miles away from Earth. The idea is noteworthy because it is the professor's most recent publication. 10 days before his death, the sharp mind's final research was published in a paper titled Smooth Exit from Eternal Inflation, which he co-authored with Thomas Hertog, a physicist at the Catholic University of Leuven in Belgium. Stephen Hawking proposed a proposal for the birth of the universe that could answer several unanswered issues. Despite the fact that it was his final work, the paper was a final examination of one of his earliest theories. If the JWST succeeds in proving the existence of the multiverse, the scientists behind it will be strong contenders for the Nobel Prize. Stephen Hawking, however, would be ineligible for the Nobel Prize because it cannot be granted posthumously. What is the multiverse theory according to Stephen Hawking? The multiverse theory argues that our universe, with hundreds of billions of galaxies and practically innumerable stars spanning tens of billions of light years, may not be the only one. It's possible that our universe isn't the only one out there, and that there are many more. There may be an infinite number of universes, each with its own unique cosmological rules, stellar populations, and intelligent civilizations. As a result, our world may simply be a small part of a much bigger collection of realities, together referred to as a multiverse. However, the multiverse's connotation of doppelgangers or clones makes it, as some people remark, weird. In other words, the same patterns are bound to repeat themselves since there are a finite number of ways to organize particles in any particular universe according to this logic. That would imply that at some astronomical distance, a carbon copy of you is perusing the replica of this post. And because there would be an endless number of worlds, there would be an infinite number of these particular scenarios coinciding. The multiverse is a concept that appears in a few domains of physics and philosophy. However, the inflation theory is the most well-known example. Inflation theory describes a hypothetical event that took place when our universe was only a fraction of a second old. In that short period, the universe went through a phase of tremendous expansion, expanding several orders of magnitude beyond its previous size. Our universe's inflation is considered to have ceased some 14 billion years ago. Inflation, on the other hand, does not terminate everywhere at the same time. It's possible that while inflation is slowing in certain areas, it's still going strong in others. While inflation halted in our universe, it is possible that inflation continued and continues even today in other, much more remote locations. Separate universes can pinch off from bigger inflating expanding universes, resulting in an infinite sea of everlasting inflation containing a plethora of distinct universes. Each universe would develop with its own laws of physics, collections of particles, arrangement of forces, and values of basic constants under this everlasting inflation scenario. This could explain why our universe has the qualities it has, especially those that are difficult to explain using simple physics, such as dark matter and the cosmological constant. Some scientists believe that the most compelling evidence for the multiverse is the existence of intelligent life capable of making cosmic measurements. They see it this way. Certain elements of our universe, including the longevity of stars, the amount of carbon, the availability of light for photosynthesis, and the stability of complex nuclei, appear to be distinctive and important for maintaining life. However, if you're given a random universe, none of these characteristics is likely to be present. The multiverse provides one explanation for why all of these characteristics are beneficial in our universe. Alternative universes exist. Even so, we keep an eye on this one since it can host complicated life. But Hertog says that when they reached this point in their understanding of the multiverse, Hawking was not satisfied and asked her to join him in his quest to manage the universe. Finally, they developed a scientific method for transforming the multiverse idea into something that could be tested. Since the theory cannot be tested if the number of universes in our multiverse is large or infinite, string theory, a branch of physics that attempts to reconcile quantum mechanics with gravity and Einstein's theory of relativity, was a guiding principle for both Hawking and Hertog. They devised a new theory of everlasting inflation based on a barrier at the start of time. The theory proposes that tracing the growth of our universe backwards in time would eventually lead us to the threshold of everlasting inflation, where our familiar concept of time will lose all meaning. Based on that barrier, the new theory predicts a finite structure of universes emerging from the Big Bang. Using this idea, it is possible that other universes like our own might have formed at the same time, and that there may even be primordial gravitational waves that match the inflation of the universe at that time. However, scientists will need additional data and a deeper understanding of string theory before this new model can be confirmed to be correct. On the other hand, Stephen Hawking and his PhD student Bernard Carr proposed in 1974 that during the early moments of the Big Bang, 13.8 billion years ago, lumpy regions with excess mass may have formed in the cosmos and thereafter collapsed into black holes. However, the scientific world did not accept their idea, but the current studies suggest that Hawking may have been correct with some tweaks. The existence of black holes has been confirmed, and we even have one or two pictures of them. The James Webb Space Telescope may finally be able to prove the existence of primordial black holes and find proof of the multiverse theory. Finding the origin of primordial black holes would also help scientists solve another cosmic mystery that has stumped them: the vast amount of radiation discovered from distant, faint sources distributed throughout the cosmos. Let us know what you think of Stephen Hawking's multiverse theory in the comments section below. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.